Hello there, welcome back. This is lesson 7 in the Unit 11 unit. So yesterday we talked about, how to label voltaic cells in a lot of detail. Today we're gonna just continue practicing with that with a few more very similar questions, asked in a slightly different manner. So the best way for you to go about doing this is to follow along with one of the questions and then try the other 3 on your own. Then, come back to the video and check yourself for further explanation. Now, I will say that some of the pictures on the worksheet are a little bit fuzzy, so if you can't read them, I will, go and fix that a little bit, at least in the video. So it looks like tonight you guys have a voltaic cell capsule learning due tonight. So basically the stuff we've talked about today and yesterday. Just make sure that you are following the calendar and schedule posted on the website and whatever other announcements your teacher makes. So let's just jump into this with the first question. So these pictures look like what we were talking about yesterday. Let's kind of annotate it a little bit and then answer the questions. So it looks like we have to figure out the anode, the cathode, the direction, which increases, which decreases, and then the 2 half reactions. So before we even get started, we should write Leo Gur, red cat, and ox on top of the page, side of the page, your hand, wherever you find it useful. So in order to figure out which is the anode, which is the cathode, you have to use table J, and whichever one is higher up is the anode. So in this case, copper is the anode, and we know oxidation takes place. That's where NOx comes from. Silver is lower, which means it is the cathode, and that is where reduction happens. That is where red cat comes from. So we can answer the first, and then before we even jump into questions, we know electrons go anode to cathode. That was a really weird arrow. Okay, so the anode is copper. The cathode is going to be our silver. And then the direction of electrons are from copper to silver. And again, that's anode to cathode. Okay, so when we're talking about which gets bigger, which gets smaller, if we think about it, the cathode is being reduced, and that means you're gaining electrons, you're gaining stuff. So doesn't it make sense that the side that's gaining stuff gets bigger, and that the anode, which is being oxidized and electrons are being lost, doesn't that make sense that's getting smaller? So one of the things that I had mentioned the other day, maybe yesterday, was a fat red cat, meaning it just keeps getting bigger. And then the second half of this way to remember it, you guys have to work for it a little bit. Go to the website and scroll to the very, very bottom of Unit 11, and the rest of the kind of helpful hint is there. Okay, so that means the cathode increases in mass, and that is our silver. And then the copper anode gets smaller or decreases in mass. Our oxidation half reaction looks like copper 0. So we have the copper 2+ ion in the liquid and the copper electrode. So this one's easier to see. Copper 2+ and 2 electrons. So remember, oxidation, you are losing electrons. Electrons are a product, and you have to make sure the charges on both sides equal up. So we have 2 electrons to cancel out the +2 copper charge. Then reduction looks like Ag +1 electron gives you Ag0. And that's all these questions are asking. The only thing new that we've added today was the increase and decrease in mass. If you wanted to go the extra step and write the balanced redox reaction, you could do that, and it would look like CuO plus 2 Ag plus 1 gives you... So that's what the combined one would look like if you wanted to go ahead and take that extra step. Next is this one. So we have the balanced redox reaction here. So we know that Ni is a plus 2. Let me get a different color, that's hard to read. Ni, switch colors, plus 2. You know that from right there. And then Al has a plus 3 charge. So if we look at table J, aluminum is higher, which makes it the anode, and that makes nickel the cathode. And again, that's where reduction happens, and electrons move anode to cathode. So if we're filling this out, aluminum is the anode, nickel is the cathode. Electrons move from aluminum to nickel. So anode to cathode. We said the cathode increases in mass, and that's what nickel is. And then the anode is losing mass, and that is aluminum. And then if we're adding our half reactions, aluminum looks like this. I hope by now half reactions make some sense. And then reduction looks like this. Ni plus 2 electrons gives you Ni 0. And if you wanted the combined reaction, it is 2 aluminum plus 3 Ni plus 2 gives you 2 Al plus 3 plus 3 Ni 0. But again, they already gave that to you, but you can kind of see how that works. Next, number 3, halfway done. Again, look at table J. Mg will be the anode, it is higher up. That means copper is the cathode. Reduction happens at the cathode. Oxidation happens at the anode. NOx, red cat. Electrons move anode to cathode. So now we can kind of jump in and answer all these questions pretty quickly. So we said the magnesium was the anode. Copper was the cathode. Direction goes magnesium to copper. So anode to cathode. The copper cathode increases in mass, and the magnesium anode decreases in mass. And our oxidation half reaction looks like this. And the reduction half reaction looks like that. And it did give you the balance reaction should you want to look at it. So after a while, these things do get very repetitive. Last one. So this says Zn plus 2. It's kind of fuzzy. This says Fe plus 3. So this is iron, and this is zinc. So if you were having issues seeing that, that's what that says. So looking at table J, zinc is the anode because it is higher up. It is going to be oxidized and lose electrons. Fe is lower, it means it's going to be the cathode. That is where reduction occurs and electrons are gained. So electrons always move anode to cathode. And if you take a second to think about that, the anode is losing electrons, being oxidized. So it's going somewhere, and then the cathode is accepting and gaining those electrons. So that is why electrons flow that way. Okay. So let's jump into this last batch of questions. The anode is zinc. The cathode is iron. Direction of electrons always goes anode to cathode, so zinc to Fe, anode, cathode. The iron cathode increases in mass, cannot speak today, and the zinc anode decreases in mass. So we're going to jump into these half reactions. Again, all oxidation half reactions kind of look the same. All reduction half reactions kind of look the same. So hopefully this makes sense. If it doesn't, obviously ask for help. We will help you. It is literally our jobs to help you. Okay, that is what oxidation looks like. And then the reduction half reaction is like that. And the balanced reaction is on the reaction on the bottom. It's not actually balanced, so if we did want to balance the combined reaction, it would look like 3ZN0 plus 2 Fe3 plus gives you that and 2 of those. So that is what, if you want to take the extra step and balance and combine the reactions, that is what it would look like. Last 2 questions on the very bottom of the page. In terms of atoms and ions, why is the mass of the anode decreasing? So we can say electrons, ions are lost during oxidation. And then why is the cathode increasing? Well, electrons and ions are being gained. Electrons, ions are gained during reduction. Remember, think of Fat Cat, and the other half of that is on the website that you will have to find yourself. So that is it. Make sure you finish the calcium learning assignment that is due tonight on Voltaic cells. Tomorrow we start electrolytic cells, and then we will review them, both of them, on Thursday, and then case study on Friday. On that note, that is it, and have a wonderful day.